Okay, so this is Math 133, question 5.4. So the first question is, a tank has the shape of a downward-facing circular cone with a height of 10 meters and a base radius of 4 meters. The tank is filled 8 meters high, so assume that the density of the water is 1,000 kilograms per meter cubed. How much work is required to empty the tank by pumping the water to the top of the tank? So the best way to start this off is to draw a figure so you have a visual. I've already done that, where you can see that the 10 meters for the entirety of the height of the cone with the 4 meter base radius, and the water is up to 8 meters high. So starting off, we need a formula that goes with this question. So W equals the definite integral of A to B of sigma times the area of its cross section times the distance dy. So using this formula, we will write down what was given us. So we take sigma, and we know that sigma is the density of the water, so sigma is 1,000 kilograms per meter cubed. And now we need to find the distance. So distance will be 10 minus y. The reason for this being that the water at the very bottom of the cone would take much longer to get out of the top of the cone than the water at the very, very top. Since the distance it can't be accounted for, we need to do this. So now that we have this, we need to find the area. So the area's formula is pi r squared. And we currently don't know what r is. So to do this, we need to do triangles, like so. We'll make this triangle r, this triangle y. And now taking the height and things, we will do 4 over 10, so the base radius over the entirety of the cone equals r over y. And since we're trying to discover r, we're going to solve for r. So r equals 4 over 10 y. And now that we've discovered the area, we can plug this as well into the original question. So area of y equals pi 4 over 10 y squared. And if you wanted to simplify this, it could be pi 4 over 25 y squared. So now that we have all these, we can do the original formula. So W, or work, definite integral from 0 to 8 times 1,000 times pi 4 over 25 y squared, and 10 minus y dy. And don't forget to put dy at the end. Now you have all this. You need to pull out the constants and put the new equation as 1,000 times pi times 4 over 25 with our definite integral from 0 to 8, and y squared 10 minus y dy are left in their original places. Now it's time to both simplify this and distribute it. So 160 pi, that is evaluated from 0 to 8, and then on this side is times everything. So 10 y squared minus y cubed dy. Now we will evaluate this entire integral. So 160 pi, then 10y cubed over 3 minus y to the 4th over 4, and this will be evaluated from 0 to 8. So now we can just plug in 8 anywhere we see a y, because anything times 0 would be 0. So it will become 160 pi, 10, 8 to the 3rd over 3 minus 8 to the 4th over 4. And this could be considered like the very last thing. If you wanted it completely calculated out, though, it would become 327,680 pi over 3 joules. And this could be considered your final answer. Moving on to the second question, which is true or false. Assume Hooke's law applies. It took 24 joules of work to stretch a spring from its natural length of 1 meters to a length of 2 meters. The spring constant K is given by K equals 16 newtons per meters. So, Hooke's law has an equation, and it is this. Force equals constant K x dx. Then we have work equals the definite integral from A to B kx dx. So first we must set up our integral. So for the bounds, we need to remember that the natural length is always 0. And for our natural length, as we can see, it is 1 meters to 2 meters. So what we need to do is 2 minus 1 equals 1. And that gives us our bounds. So from 0 to 1, that is our bounds. And now we can just plug in our information that we've gotten from up here. So 16x dx. And now we will solve our integral. So 16x squared over 2 with its value from 0 to 1. And now since it's divided by 2, this will cancel out, and 16 will become 8. So this equals 8x squared. And now we can plug in our bounds to this 8x squared. Now anything times 0 will always be 0, so it is just simply 8 times 1 squared minus 0. And 1 times anything is just itself, so it equals 8 joules. This would mean that the question is false. And it is not 24 joules as it is previously stated up here, but 8.